We'll start today's session. Yeah, thanks for joining session number 4. Today by the end of the class, we want to try to finish making our game, which I have here, kind of just show you what we'll be able to do. But okay, so yeah, coming back. First let's go over whatever the questions from last time. Okay. So yeah, where did they go? Huh. Oh, what? Let me open them. Oh, I guess maybe I didn't post the questions. Okay. So yeah, let's go over some examples. Okay. So last time we went over maps and functions. So kind of what we want to do. Let's do like an example. Let's create a function that will. Let's start with the concept I want to talk about today. So one of the concepts I want to talk about today is recursion. So we'll cover a little bit of theory, and then also talk about functions in that way, and then we'll do some work on the project. So what is recursion? So recursion is basically a way of repeating steps and going down to the base case until you get like an answer and then coming back. Let's say like the classic example is let's say you want to count the numbers from 1 to 10. Let me start screen sharing. So if you want to count the numbers from 1 to 10, a couple times ago we went over how to do this in an iterative way, right? We do like a for loop, let whatever x equal to 0, x is less than, or we wouldn't do 1 to 10, right? X is less than 11, then x plus plus, and then we'll add to our sum variable. So right, this was the way how we would do it iteratively. Right. And so, last time we went over functions, right? So how do we encapsulate or how do we wrap this in a function? So the way to wrap this in the function is, let's say, function, count. If we want to do something like that, and then we would say, okay, count has like an x into it. So then, or it'll be say, count to number. So for that x equal to 1, x is less than number plus 1, x plus plus. So we're talking about how to encapsulate whatever our counting from 1 to 10 in a function, and then you can do console.log sum or something like that, or you can return sum, and then let me. Right. So then so now this is the iterative way to count from 1 to 10. So we'll copy this function that we've made, right? And so now if we want to count to, let's say, 100, we'll do count 100, and it'll return 50, 50, right? If we want to do count 20, 20, it'll return that number. So yeah, that was like one example of functions. And then let's talk about hash maps also. So we're to also talk about our recap. So the way you define a dictionary or a hash map in JavaScript, you do something like, let's say, let map equal to, and use the curly brackets, and let's say whatever our, but we wanted, I think one example that I wanted everyone to talk about was favorite food items of their family. So let's say you'd say father, his favorite food item is khichdi. Mother, pani puri. Let's say brother, pizza. Sister, what else is left? Chinese or noodles. Alright, so this is an example of a dictionary or hash map. Alright. So we've defined our map like that, right? So then we'll do map of, okay, what does my father like? Oh, khichdi. What does my brother like? Pizza. Sister, and then mother. Right, pani puri. And then and then what I wanted to say is like, okay, you can also use multiple data types with this map. Let's say, okay, you're playing a game, so what is everyone's score in the game? Let's say father has 100 points, mother has 50 points, brother has 80 points, and sister has 120 points. In your, let's call this scores, right? So then we use that scores, and then we can do the same thing, right? Yeah, scores defines that. And we refer to it by the string index, right? So that's a couple examples of different maps and functions. So and then whatever the concept I want to talk about today is like recursion. So recursion is like a very powerful concept in computer science. It's like a different way of calculating things. So yeah, going back to our initial example of let's say we only want to count something from 1 to 11 or 1 to 10, right? So this is, we'll call this function count iterative, right? So this is how we would do it in an iterative fashion. Iterative means that you're doing it like one after another, and usually we'll do that with a for loop or some sort of loop. But there's also the concept of recursion. So we'll do, okay, how would I do the same count recursively? Yeah, count recursive. Kind of what I was talking about earlier. You take in recursion, you take a bigger problem and you break it down into a sub problem. You break it down into like a smaller version of the problem, and then you keep on breaking it down until you hit like a smaller subset of the problem where you know what the answer is. So for our situation, and then like the place where you know what the answer is, that's called a base case. So yeah, an example. So we're gonna write this function count recursively. So we say if number is equal to 1, or we'll say if number is less than 1, then we'll return number. Else we'll do return let's say right. So what will this do? This will say, okay, let's say we want to know all right, let's do an example first. Like if we want to count the numbers from 1 to 10, right? We'll do okay. What 10 plus the sum of my numbers from whatever 1 to 9, right? Let's start with 1 to 5. I think that'll be easier to type out for all the different scenarios. Okay. So then, so what will this do? It will say, 5 plus 4 plus the sum of 3, 2, 1, and then we'll do plus 3. Plus 2, which is the sum of 1. And at this point, we know, okay, sum of 1, we know what that value is, right? That's our base case. So that is 1. So then, then we'll come back and say, okay, I know what this is. So 2 plus the sum of 1, oh, that's 3. I know that. Then we'll come here and say, oh, 3 plus 3, okay, 6. I know that. And then we'll come back here and we'll say, okay, 4 plus 6, oh, okay, I know that. And then we come up here and we say, oh, it's 5 plus 10. Okay, then that means our answer is 15. So that's how we kind of do that process recursively. So let me show you. So count. Right, we had our count before. That was the regular. Now we have count recursively, and we'll do 10, and we see that it gives that same answer, right? So okay, maybe it might be better to show what is happening. Let me do that. I'll do a console.log so we can see that what is happening at every time. Yeah. So you can see it goes all the way down and then it comes all the way back up. But if you see here, it seems like we're doing a lot of repetitive work, right? It should only take whatever 5 or 6 steps, but it's doing this, multiple times. And why is that? Well, it doesn't work. Let's say like the way I was showing you, it in this way I'm showing it says like it only goes down in one scenario, But what it actually does is like at each step, it'll calculate everything and then come back and calculate everything, come back, right? So it does, multiple excessive work. So there's a technique called memoization. And that way, basically, like you store whatever previously computed results. So like, and basically you make sure that you don't do the same thing over again. Um, so yeah. So let's say like how would we use that? So we do let memo equal we'll make it a dictionary, right? And then we'll say let's say left number is equal to 1. Then we'll do memo of number is equal to number. Otherwise we'll do memo is equal to okay. So if our number is in memo, then we'll return that. Oops. Else we'll return, we'll do this calculation and return it. Okay. So this is basically we are using a dictionary and a hash map to make sure we're not calculating the same thing over again. Yeah, yeah. All right. So now we'll do the same count recursively 10. Oh, whoops. Yeah. We have an issue here. Okay. So yeah, we can see count recursively still returns 10, but this time it's taking a fewer number of steps. Yeah. Okay. And then, so yeah, let me also do the same thing. Let's print it out so we know what's happening. Okay. See, and then we have that fewer number of steps because it's not recalculating things that we have done already. Okay, so that's an example of, okay, this is like an iterative calculation, which we go in sequence 1, 2, 3, 4, whatever, and this is called whatever recursion, where we break a bigger problem into sub problems until we get to like a base case, and then we return that result. So there's also this thing called like tail recursion versus regular recursion. And this is an example of tail recursion because we do our recursive process at the end versus other places. Yeah, okay. I think that's kind of the theory example. I don't know. Anuj or Nachikeet, do you guys want to add anything about either the recap or questions about recursion? Kind of just like the basics.
You explained it very well, so there is nothing from my side.
Okay.
Anuj wants something, then
Yeah. No. All right. Then we'll start with kind of the project, whatever, finishing up our game for today, right? So let me go back to the code. So yeah, this is our code, and this is okay. That's not the place we want to be. Okay, so this is where we were at last time, and then this is where we are at last time, and then we'll open our code, our project. All right. So last time we have this background, and then if we play space, we can hear some music. Okay. So now what we want to do is we want to add our two characters and maybe create a game out of that. So we'll work on that. So first thing, we're gonna get rid of this array. Both these arrays, we won't need them. Okay. All right. So we'll define our characters. So Krishna, Makan. All right. Then we'll do. So direction. This is gonna be the movement of the character. So we'll say we'll start off in this direction, and then this speed we'll start off at. And then we'll say our starting score, we'll make it 1, and then we'll make our starting score 0, and then let's do, this is the x position of Makan, so mx we'll say is 0, and let my equals 0, right? So these are the variables we're going to use. So this is the character for Krishna, Makan, character for Makan. So I'm saying character, but in the code, in the framework, the terminology is sprite. So this is the variable for the Krishna sprite, and this is the variable for the Makan sprite. So let's create that. So in our setup, we will now also define whatever our sprites for our characters. Okay, so we'll do Krishna, create sprite, and we'll say let's create it at position 400, 200, and then we'll do Makan create sprite, and we'll do 500, 200, and then let's add our images to it. So it'll be Krishna dot add animation, and we'll call it chasing. Is this the name of the animation? And then this is the we have to put the place of the image, and we'll do and our image is called Krishna.jpg. And then we'll do the same thing for Makan, and we'll call this running because Makan is running away, and then it is container.png. Oh, okay, I think, wait, let me switch back. This doesn't have the right images. Alright, so yeah, okay. So this is what we did so far, right? So we have create sprite, we add the images. Yeah, let me copy this now. Alright, so this time when it loads, it'll load the Krishna image and load the Makhan image. Okay. Okay, so we see we have the Krishna image and we have the Makhan image. Alright. So the next thing we want to do is we want to make sure that the Makhan shows up in a random location. So how are we going to do that? So there's this code. Basically, we'll set mx equal to a random number that is between 0 and the width. And width is like basically the width of our screen, our canvas, and height is the height of our canvas. So we'll say the x position should be a random number between 0 and the width, and the y position should be a random number between 0 and the height. So now instead of using my 500, 200, I will do mx and comma my. So that will make sure it shows up in a random position. Okay, so we'll do that. So every time I reload, the container or Makhan will show up in a different location. See? So, okay, so we did that part. Okay, next we want to add the movement. Okay, so how are we going to do that? We'll do it here. Okay, we'll say, okay, function movement, and then we'll give it sprite. Comma, key code. So we're creating a function called movement, and inside movement we will define how we want our character to move. So okay, how are we going to do this? Basically what we're going to do, there's this variable called key code, and it will have the value of, okay, which arrow key are we pressing. So we'll do if key code is equal to up arrow, then we want to set the movement of Krishna. So Krishna dot, or we'll do it this way. If direction, or let me sorry. We'll do these. We'll set the movement of Krishna. So Krishna dot set speed, and we'll say if we press the up arrow, then our direction should be. This is like in angles, so it should be 270. Our direction should be 270 degrees. So and then our speed, we're going to say initially it's going to be 3. So we'll say our it's 270, and then we'll do the same thing for the other directions. So up, our degree is 270. If we go down, it's going to be 90. Then if we go right, it's going to be 0. And then if we go left, it's going to be 180. All right. So we'll do that. right? So now we can move our Krishna character. All right. Okay. And then, all right. So let's continue with the game. So this is our function for movement. All right. Then we can do how do we calculate if the container and Krishna have like if Krishna has caught the container. So there's this. Oh, I didn't talk about this. So in our draw function, we have to do at the end we have to do draw sprites, and that will actually show the image on the screen. Yeah. So okay. So this is the calculation for our. How do we calculate if Krishna and the Makhan have met? So there's a function called collide. So what we'll do, if Krishna dot collide Makhan. So if Krishna and the Makhan are meeting, what we're gonna do is we want to increase our score, and we want to basically move the position of the Makhan. So yeah, let's start like this. So if Krishna catches the Makhan, what do we want to do? First thing I want to do is I want to increase our score. So score +1. And then I want to recalculate I want to calculate a new position for the Makhan. Okay, and then the same thing we did above, mx and my, right? Then we'll do Makhan dot position dot x equals mx, and Makhan dot position dot y is equal to my. Alright. So, and then we also want to display our score. So, the code we had last time, we want our text size to be 50, we want our color to be blue, we'll fill that, and then we'll print out the score variable on the top left corner, right? And every time we catch it, we're adding 1 to the score. So, right. So over here we have our score is 1, but let's see what happens if we catch it. Oh, our score became 2, 3, whatever, right? So as we catch it. So and then all right, let me refresh. Right. Okay, cool. And then let's say like one thing I wanted to add. Let's say how do we make sure like that Krishna runs? Because right now we're always going at the same speed. No matter what you do, it's the same speed. So how do we add that? Oh, okay, that's here. This was, yeah. Yeah, whatever you do, you're going at the same speed. And then another issue, if we go to the end of the screen, then we keep on going. and we leave the screen. So let's fix this issue first. How do we stay within the boundaries of our screen? So for that, let's create a function called check bounds, and we pass in Krishna. So we'll create a check bounds function here, and then we'll do if sprite dot position dot x is greater than our width, then what do we want to do? Then we want to make sure the direction is reversed. So we'll do direction equals 180, right? and then we'll say if, and then we'll do this for all the 4 conditions, is less than 0, then we want our direction to be 0, and then if our y position is greater than the height, or is less than 0, and then so basically this means if we keep on pressing up, we leave the screen, and if that happens, we want to change our direction to down, and this is the opposite case. If we're going down and we leave the screen, we want to change our direction back to up. So this will reverse our direction in check bounds, and then yeah, we'll do direction equals 270. Direction equals 0, and direction equals 180. Changing this a little bit. So in movement, we're only going to set the direction now. And in our draw function, we'll set the speed, and based on what the value of the speed is and what the value of our direction is. Yeah. I'll set our initial speed to 5 also. Okay. So see now what happens when Krishna reaches any of the boundaries, he comes back. And same thing with those directions, left and right. But same thing, like we're always going the same speed. We can't run. So how do we change that? So we're going to add some logic for that this time. Okay, so then we go to our movement. Over here right now what we're doing is we're just setting the direction. But what if I want to speed up? So how do I do that? So what I'm going to do is if my direction is currently whatever, like if I pressed up multiple times, so like the last time I pressed up, my direction was 270, and then I pressed again. So if my direction hasn't changed, then what I'll do is I'll add 2 to the speed. Else, I'll just set my direction. So the first time we press up, it'll set the direction, and the next time it'll speed up, right? So let's do that for the rest. So doing that for down, doing that for right. Okay. Refresh our game. So right now you can see that we're only going in one direction. But now I want to go faster. And you see, as I press the arrow keys, the speed of my character goes faster. And it goes faster and faster, and it's you can actually run now. All right, but this doesn't work, right? Like another issue is like if we change directions, then we should slow down our speed, right? But that's not happening. So let's fix that too. Okay. Here. So the first time we change our direction, we'll reinitialize our speed. Another thing I want to change is like, okay, every time we start, then Krishna starts moving automatically. So let's change our initial speed to 0. Okay, so then we'll make our code changes and we'll see what happens this time. Okay, so now we don't start, and you can see if I change the direction, our speed goes back to normal. But let's say I'm going this fast, right? And then I change my direction, then our speed becomes normal. And then yeah, you can also play the music while you're playing the game. But yeah, that was it. That's we have a game where we have two characters, and we have random position, and you can catch the character. So kind of let me just go over a quick recap of what we did. First, we defined two characters for a game, Krishna and Makhan, and then the initial direction, initial speed, our initial score. In this, we declared variables to hold the random position of the Makhan. And then over here, we declared the game character for Krishna. And over here, we declared the game character for the Makhan. And we used the random function to generate a random value for the X position and a random value for the Y position. And we created that. And then we created a function called movement that would decide, okay, what is the direction to set for my sprite or my game character. And then we said, okay, if we choose up arrow, our direction should be 270. And then in this scenario, you're pressing up arrow the second or time or like whatever successive time, then we'll increase our speed. But if you're pressing up the first time, we set our direction to 270 and we reinitialize our normal speed to 5. So then we do that same thing for the down arrow, the right arrow, the left arrow. And then in this key press function, that's when we're checking what key has been pressed. That's when we call our movement function. And we also created a new function called check bounds to make sure if our game character goes outside the boundaries, then we reset the direction and point them back to the center of the screen. And over here, we're displaying the whatever score. And then this is where whatever based on whatever speed value we've calculated and direction we calculated, we'll set that speed for our Krishna character. And here we're checking, okay, has Krishna caught the Makhan using the collide function. If he has caught it, then we'll add 1 to our score. We'll choose a random location again for the Makhan. And then here, this is we're calling our boundary function to make sure we haven't gone outside of the screen. And this is the function that will actually display it on the screen. Okay. Did someone message? Oh, okay. Yeah. So yeah, I just wanted to show you like we only wrote maybe 10-15 lines of code based on what we had yesterday. And yeah, we now have like a simple game. Does anyone have any questions? Or yeah, no questions? Okay. I don't know, Anuj or Nachikit, do you want to add anything? If not, then we'll end for today, and then I'll post some questions about like okay, how to practice recursion. Nothing? Okay.
Nothing from my side also.
All right. So yeah, thank you everybody for coming to the 4th session now, and yeah, it's a good journey. I think I decided we'll do 10 sessions, so we'll meet at least a couple more times. But yeah, I guess that's it for today. All right, thank you guys so much, and I'll post this on YouTube again.
Thank you.
Yep. Bye.
Bye.